Imagine a world where you can indulge in your favorite burger guilt-free, knowing it didn't harm animals or the planet. This vision fuels the excitement around lab-grown meat, a groundbreaking innovation that promises to revolutionize the food industry. Advocates claim it's the answer to reducing greenhouse gas emissions, saving land, and creating a more sustainable future. But beneath the surface of this compelling narrative lies a set of assumptions that demand closer scrutiny. Is lab-grown meat truly the sustainable solution it's claimed to be? Or are we focusing on the wrong problem? At the heart of the argument for lab-grown meat is the belief that traditional livestock farming is unsustainable. Critics argue that raising animals for food uses excessive land, energy, and water, painting a grim picture of resource depletion. But this perspective often conflates industrial farming with natural, pasture-based livestock systems, which operate on entirely different principles. In pasture-based systems, animals graze on land unsuitable for crops, enriching soil health, promoting biodiversity, and contributing to a regenerative ecological cycle. Unlike industrial farming, these systems don't exhaust resources, but rather support a balanced and sustainable ecosystem. Yet, lab-grown meat proponents often disregard this distinction, framing all livestock farming as an environmental burden. One of lab-grown meat's strongest selling points is its potential to reduce land use. The claim suggests that livestock monopolizes vast amounts of land that could be repurposed more efficiently. However, this argument oversimplifies the reality. Animals grazing on pastures aren't depleting land in the same way crop farming does. Pasture-based systems use non-arable land that wouldn't support crops and enhance, rather than degrade, the land over time. This makes the claim of lab-grown meat's land-saving benefits far less compelling when viewed in the context of sustainable grazing practices. Then there's the hidden cost of energy. Producing lab-grown meat requires sophisticated bioreactors, sterile environments, and nutrient feeds to cultivate animal cells. These systems need continuous power to maintain optimal temperatures and prevent contamination, consuming substantial energy throughout the process. While renewable energy sources can offset some of these demands, the global energy grid still relies heavily on fossil fuels. As a result, lab-grown meat's energy use could compete with other sectors and inadvertently sustain the reliance on non-renewable resources. The notion that lab-grown meat is inherently clean ignores the reality of energy competition and its broader environmental implications. The environmental debate surrounding lab-grown meat also hinges on its potential to reduce greenhouse gas emissions, particularly methane from livestock. But methane emissions from livestock are part of the biogenic carbon cycle, a natural process where methane breaks down and is reabsorbed by plants. This cyclical system has been part of Earth's balance for millennia. In contrast, the production of lab-grown meat depends on crop-based nutrient feeds, which involve fertilizers and pesticides that release significant emissions. Without a fully renewable energy infrastructure, lab-grown meat could match or even exceed the environmental impact of sustainable livestock farming. Beyond environmental concerns, lab-grown meat raises questions about nutrition. Advocates highlight its potential for customization, suggesting that vitamins and minerals could be added to make it healthier. But replicating the intricate nutrient profile of real meat is a complex challenge. Natural meat contains essential proteins, fats, cholesterol, and micronutrients that work together in ways science doesn't fully understand. The history of vitamin supplements offers a cautionary tale. Attempts to isolate and replicate nutrients have sometimes led to imbalances or diminished effectiveness. Lab-grown meat could face similar hurdles, creating products that mimic meat's appearance but lack its full nutritional benefits. This brings us to the broader question: are we solving the right problem? While industrial livestock farming has undeniable environmental drawbacks, pasture-based systems offer a sustainable alternative that works with, rather than against, nature. Meanwhile, the environmental impact of crop farming, including monocropping and its energy-intensive practices, remains largely unaddressed. Lab-grown meat would still rely on crop-based nutrient feeds, perpetuating the demand for large-scale agriculture and its associated challenges. By focusing solely on replacing livestock, we risk overlooking the more significant issues tied to crop production and energy use. Lab-grown meat undoubtedly represents an impressive technological achievement, but it may be more of a distraction than a solution. Its promise to reshape the food industry is built on assumptions that often fail to account for the complexity of agricultural systems, and the interconnected nature of environmental challenges. Instead of shifting the problem from one area to another, a more holistic approach is needed. One that addresses the root causes of resource consumption, whether in crop farming, energy use, or livestock management. The excitement around lab-grown meat is understandable, but it's crucial to question whether it's the step towards sustainability that we need, or simply a different set of challenges. Real progress lies in looking beyond the hype and focusing on solutions that address the full spectrum of environmental and nutritional impacts. To truly create a sustainable food system, we must balance innovation with a clear-eyed understanding of the bigger picture. It's time to rethink not just what we eat, but how we produce it, ensuring a future where food and the environment thrive together. Thanks for watching. If you found this exploration thought-provoking, be sure to like, share, and subscribe. Let us know your thoughts in the comments below, and join us in shaping the conversation about the future of food and sustainability.